Hi, thanks for joining me. To celebrate the new year, I thought it'd be nice to do a number theory problem that involves the number 2022. So here it is. We want to find a positive integer that is composite and contains 2022 ones and 17 in its decimal expansion. So it's going to be of this form here. So it's going to be some number of ones, followed by a 7, followed by another bunch of ones, and in total there'll be 2023 digits, 2022 ones and 17. And we want to find a number of this form which is composite. Okay, so if you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to jump straight into a solution. Okay, so let's take an arbitrary number of this form and call it Tn, where this n here just denotes the position of the 7. So if this guy here is our first digit, this is our second digit, and so on, 7 is going to be in our nth digit. And remember, we've got 2023 digits in total, 2022 ones and 17, so the last guy here is going to be the 2023rd digit. Cool. So essentially we want to find some n such that Tn is composite. Now, let's have a look at what this number here is here, but write it kind of as sums of powers of 10. So this is equal to, well, 10 to the 0, corresponding to that guy there, plus 10 to the 1, plus so on, all the way up to 10 to the, this guy here, the 7 column, is going to correspond to 10 to the n minus 1. So let's just write out 10 to the n minus 2 first, plus 7 lots of 10 to the n minus 1, plus 10 to the n, and so on, all the way up to 10 to the 2023. Like so. Not 2023, 2022, sorry. Like so. So that's what Tn is, essentially just written as sums of powers of 10, but of course we can just write this as 10 to the 0, plus 10 to the 1, plus so on, plus 10 to the 2022, and then take off one of the powers of 10 here to go into this sum, and then we're left with 6 times 10 to the n minus 1, like so. So all I've done is written Tn essentially as sums of powers of 10, and now what we want to do is kind of work out some n such that this guy here is composite. But of course, this is a very, very big number, so we want to essentially see if we can find some, say, small prime factor of this guy, and then, you know, for a particular n, and then we'll be done in showing that this guy here is composite. So we want to find a small prime number that divides this guy here. So if we tried 2, well, 2 wouldn't work, because hopefully it's clear to see that this number here is always going to be odd. Well, what about if we try the prime 3, so does 3 divide this guy here? Well, unfortunately it doesn't as well, because we can remember, we can use the trick that a number is divisible by 3 if and only if, when we sum up its digits base 10, we get a number that's a multiple of 3. So if you sum up the digits here, we're going to get 2022 lots of 1s, that's just 2022 plus 7. But 2022 is a multiple of 3, because 2 plus 2 plus 2 is 6. So 2022 is a multiple of 3, but 7 isn't. So there's no way that Tn can be a multiple of 3. So it's not a multiple of 2, not a multiple of 3. It's also clearly not a multiple of 5, because it doesn't end in a 5 or a 0. But it's not particularly clear. It might be a multiple of 7, depending on what n is. So let's try and see if this is a multiple of 7. And the way we're going to do that is by looking at it mod 7. So we want to consider Tn mod 7. So this right hand side here is just going to be congruent to, well, remember 10, is just 3 mod 7. So this is just equal to 3 to the 0, plus 3 to the 1, plus so on, all the way up to 3 to the 2022 mod 7. 6 is just minus 1 mod 7, so we can put a minus sign here, and then 10 to the n minus 1 is just 3 to the n minus 1, like so. So Tn is just congruent to this guy here, mod 7. I'm not going to bother writing out the mod 7s, because there's still a few more lines of algebra to go. Anyway, let me clear up the whiteboard, and we'll continue. Okay, so we have that Tn is congruent to this guy here, mod 7, and what we want to do is reduce this further, mod 7, and see if we can choose some n to make it 0, and that will mean that T of that n is going to be a multiple of 7, so clearly a composite number, and we'll be done. So how are we going to reduce this further, mod 7? Well, we're just going to look at the powers of 3. So 3 to the 0 is just 1, so it's going to be congruent to 1 mod 7. 3 to the 1 is 3, and that's just 3 mod 7. 3 squared is 9, of course that's just 2 mod 7. 3 cubed is going to be 27, or in fact we can make life easier. 3 cubed is 3 times 3 squared, so that's 2 times 3, which is 6 mod 7. 3 to the 4 is going to be 6 times 3, which is 18, which is 4 mod 7. 3 to the 5 now is going to be 4 times 3, which is 12, which is 5 mod 7. And now notice that this list is going to kind of repeat itself. So we've got 1, 3, 2, 6, 4, and then 5, and then if we were to compute the next term in this list, 3 to the 6, that would just be 3 times 5, which is 15, which is 1 mod 7, so we go from 5 back to 1, and then we go to 3, and then 2, 6, 4, 5, and so on. This loop, the cycle kind of continues. So essentially, to look at these powers of 3 mod 7, they just correspond to one of these numbers here, and the number it corresponds to essentially is dependent on the exponent we have. So the exponent, we just need to consider mod 6, because clearly this cycle here has length 6. So perhaps let's look at this in a bit more detail. Let's get rid of this line. So this thing here is just going to be congruent to, well, let's keep 3 to the 0 by itself, that's just 1. And now we're going to study these terms here. Well, it's 3 to the 1 plus 3 to the 2 plus so on, all the way up to 3 to the 2022. So we've got 2022 terms. Now thankfully 2022 is a multiple of 6, because clearly it's even, it ends in a 2, and it's clearly a multiple of 3, because when you do 2 plus 0 plus 2 plus 2, you get 6, and that's obviously a multiple of 3. So this is going to be a multiple of 3 and a multiple of 2, and hence a multiple of 6. So 2022 is a multiple of 6. So that means we're essentially going to add up this sequence a nice number of times. You don't have to worry about, you know, adding it some number of times and then having just a few terms left. We're just going to add it up a fixed number of times. So hopefully that makes a bit of sense. But let me write it out if it doesn't. So 2022 divided by 6, we could work it out. We don't actually have to work it out. We just need to know that it's an integer. Times, well, 3 to the 1 is going to be 3. Then the next number we know is 2. Then 6. Then 4 plus 5. And then plus 1. Okay, and because 22 is a multiple of 6, we don't have to worry about adding on any junk terms at the end. I guess this minus 3 to the n minus 1 is still there. But essentially we have that this line here is congruent to this line here, because these powers of 3 correspond to some of these powers here. So we essentially group these in lots of 6, and they're going to be 2022 over 6 lots of those groups of 3, and each of those groups of 6, they're going to be 2022 over 6 lots of groups of powers of 6 powers of 3. So 3 to the 1 plus 3 to the 2 plus 3 to the 3, and so on all the way up to 3 to the 6. That will be one lot. And the next one will be 3 to the 7 plus so on all the way up to 3 to the 11, and so on. So in groups of 6, and then each of those groups are going to sum up to this guy here. 3 plus 2 plus 6 plus 4 plus 5 plus 1 minus, and then of course you've got this minus 3 to the n minus 1 at the end. Now we don't actually need to work out what this is, because remember we were looking at this guy here, mod 7. So this thing here is an integer, but thankfully this guy here is a multiple of 7, because 1 plus 6 is 7, 5 plus 2 is 7, and 4 plus 3 is 7. So all in all, this is just 21. So we got 1 plus 2022 over 6, which is an integer, times a multiple of 7 minus 3 to the n minus 1. So all in all, this is just congruent to 1 minus 3 to the n minus 1, mod 7. So all we need to do now is choose an n to make this guy here equal 0 mod 7. And we can choose a bunch of different values of n, but hopefully the most obvious one is choosing n equals 1. Because then of course this guy here is just going to be equal to 1 minus 3 to the 0, which of course is just 0 mod 7. And then that will show that Tn is a multiple of 7. I hope that has all made sense. Yeah, essentially we had to think of a smart way of trying to find some way of showing that Tn was composite. So looking at it mod a prime number, and we showed that 2, 3 and 5 for obvious reasons won't work. So perhaps the most sensible guess, because we like working with small numbers, because if we work with a bigger number, this sum here would be even bigger, and you know 2022 might not have been a multiple of 18, say, or something. So it was nice that 7 works, and we showed that for a particular value of n, Tn is multiple of 7, and it's clearly bigger than 7, so it's not going to be prime, and hence composite. I hope that has all made sense. Have a very happy new year, and I'll catch you in the next one. Have a great day.